look at an assignment and that should take care of us. Business continuity is what you do when you have something bad happen. How do you keep going? And business continuity is something that you practice. And it's something that you keep up to date. What happens if we have ransomware that takes down the entire network? What do we do? Look for a new job.
Obviously, you break everything.
Well, you'd unplug everything, I guess, first, but that'd be something you'd have in your plan. So what is high availability? What does that mean? What's high availability?
But it's not hard to get a hold of the resources you need.
That means it's redundant. High availability means, like in the case of servers, you have more than one power supply. You might have more than one internet access. So high availability is partly redundancy. How about scalability? What's scalability mean in IT?
It means you can kind of scale however you want it. I don't know.
You need another whatever, you can add to it. Scalability means that if you suddenly add 30 employees, you can expand your system to keep up with those 30 employees.
And you can also reduce it depending.
It's like a good example is Amazon. Right now, they're idling along, but come closer to Christmas, they need to scale up, but then after Christmas, they need to scale down, because why do they want to pay for all this that they're not using? Diversity. What does diversity mean? I don't think it means diversity and equity.
No.
Diversity as far as IT.
That would probably be your redundancy piece, so you'd have multiple, accesses.
Multiple devices, you don't want to put everything, all your eggs in just one basket.
Yeah, you don't want all your eggs in one basket. And on-prem and cloud, how about on-prem? There's one you can tell.
On
people.
premises,
Yeah. So everybody has and part of the being in the continuity planning is what's on the premises, what's in the cloud, where are the interactions? Okay, well, business impact analysis, there we go. Disaster recovery plans are very important. What happens if everything goes to pot? How do we get everything back? Where are our backups? What are the secret keys to get into the backups? Do we have offsite backups that we can use? Do we have an offsite data center? You know, that sort of thing, like the bank. They have like data centers in a couple different places. So if one goes down, the other one takes over, or maybe just switches over easily. Amazon or Google, they have servers all over the place. Theoretically, Amazon shouldn't have had an outage, except the part that makes sure that they don't have an outage had problems with DNS, which was interesting. So you can only have so much redundancy. So we need an incident plan. We need to actually work at it. We need to look at what kind of disasters could we have? All right, we need to test it. Okay, anyway, we're gonna skip by that. So what do you need in the future? If you suddenly double the size of your employees, are you future ready? Did you, when you put in the last technology upgrade, did you plan for being able to upgrade? Did you put extra jacks in the wall? You know, can you easily buy extra switches? Did you leave enough room in your racks to put in other switches? You know, did you think ahead when you were setting things up and doing things? So you always want to plan for more than you're going to need right now, because up to this point, has IT gotten smaller and the need for connections? No, it's always gotten more and more and more. Nothing has gotten smaller. And we already talked about redundancy, which is resilience. If one firewall goes down, well, we have another one we can just throw in there, or it automatically takes over. Actually, I still have the firewall that was in this room 2 firewalls ago. It's set up, I can plug it in, we could have internet access. Wouldn't run very fast, but it would work. I kept it just because what good is it? It's an old firewall. Now another class that talked about duplicate this, duplicate that. So clustering is used. What famous companies do you think would use clustering? It combines 2 or more devices to appear as a single unit. What's a web address you use all the time that would use clustering? Starts with a G.
Google.
Google.com. They would use clustering. Amazon. You go to Amazon's website, you have no idea which server you're hitting. It appears as a single server, but there's stuff all over the place, you know, that's serving that. And yeah, I would think Amazon and Google would have 2 or more servers.
hopefully, otherwise we might have some issues.
Yep. So an asymmetric server cluster means that you have a standby server. Well, they have more than one server, Amazon does. So they're going to have symmetric, meaning they're gonna have thousands of servers. If one of them dies, they don't care. You know, they could take many of them offline and no one's gonna notice to do maintenance or put in new ones. And then when they spin it up, it becomes part of the cluster. Unfortunately, the part that makes sure that this happens failed, which that's how that works. Drives, use spinning platters. I still have spinning platters here. Many data centers are going to SSD drives because they're so much faster and they're becoming less expensive. And I do not have a stockpile of HDDs as spare parts to replace failures here because I'm not a critical 24/7 network. Neither does the college. They probably have spare parts though, I'm guessing. RAID, redundant array of independent drives. I'm practicing my Spanish pronunciation. Okay, so anyway, you never ever implement it in software. A couple of you two were in our server class, right? Yeah. So we're using a hardware device that's what it does, and that's all it does is run the drives. PERC, P-E-R-C, which is a Dell term meaning RAID controller, probably. I don't know what the P-E means, but it's a hardware-based RAID, which is what everybody uses. Software-based RAID, the disadvantage of that is the operating system has to be an operating system and take care of the hard drives. That's never a good thing. And servers are typically file intensive. If it's a web server or whatever, that has to access files quickly. And RAID 5, yeah, this is RAID 5. Oh, this is RAID level 0. We don't care about that one. This is the one that's most commonly used. And you can kind of see how it works. So what is parity? Parity is a mathematical calculation. It uses up one drive, but it doesn't literally use up one drive. It spreads it across all these drives. So if this guy gets whacked out, the controller can calculate based on this, and this, what should be on that drive. And then when you put in the new drive, it will recalculate and put everybody able to put all the information back on again. And I've done that a couple of times in here. One of my old Dell HP servers, which are now out of service, and we took them downstairs, didn't we?
Yeah.
Yeah, so they're out. And one of my Dell servers had a drive die. I ordered a new drive from eBay and put it in, and we're back in business. If two drives fail, we're done. Storage area network is like they have that at Regional West. They have like a big tower. And instead of having a single server that has the CPU and hard drives and everything in it, they have what's called a blade server, meaning they have CPU things that you slide in and out. They have separate memory things, and they have a storage area network with just a bunch of drives. And so they're separately connected. They're connected through like a little network. So if they need another CPU, they stick one in. They need more drives, they stick it in, but they're separated. And it's called a storage area network because it's a high-speed network that communicates amongst these pieces. So the reason they have separate parts is so they can easily add and subtract capacity. And they don't have to get a new server and take it apart. It's designed just to go plunk, plunk, plunk. And of course, switches. How many people can afford a redundant network that waits in the background during normal operations? Not very many people. Most of the people I work with, they can hardly afford just the part that they need. I'm trying to find my picture that Owen and I took the other day so I can get a new battery for my UPS. Offline UPS is the most common. That one, you can hear it click when the power goes down and then it clicks to put it back. An online UPS always runs off its battery. And we have an online UPS, but the battery is dead, so it just beeps. It doesn't work anymore. So an online UPS is the best because it maintains that steady voltage, where an offline one will go click. It'll have some variation, but even an offline one is way better than none at all. hot site, cold site, worm site. A bank would have a hot site. They may have a hot site, so if this one here dies, the other one takes over automatically. Cold site means that, you know, it has office space, but you have to install everything. Warm means it's all installed, but it doesn't really have everything up to date. Clouds. What is a cloud? The cloud is just somebody else's computer. And this is something that has been written about. Should we be using multiple cloud providers to do things? How do you do redundant cloud providers? I don't know. That's what I'm sure many CIOs, chief information officers, are thinking about now. That Amazon not only went down once, but it had a blip a few days later. So that's one thing that I'm sure is a subject of conversation. Recovery time. How long does it take to recover? How long does it take to recover the data? The recovery point objective is how long between copies of data do you want to wait? If you back up once a week and everything dies, you lose a week's worth of work. If you back up every day, you could use 1 week, 1 day's worth of work. Most people do daily backups because to do more than that can be very cost intensive. But some will back up every time you save a file. For instance, SharePoint keeps versions. And I'm not sure what timing it uses to create versions, but if you go into SharePoint, you can go back to different versions of your file. I was showing somebody how to do that the other day. Go back to a previous version is what it's called. And we found it and brought it back, and darned if what they were looking for wasn't in any of them. So he didn't know what he did with it. Anyway, who knows what happened? Root cause analysis. That's a good one. Root cause analysis is we're discovering the reason and the cause of the security event. That also means that you're not blaming people. You know, you're trying to figure out what caused it. What process can you put in place to prevent it? Because as a famous manufacturing guy said once, process beats people. If you have a good process and everybody uses the process, you don't have to depend on somebody remembering what to do. It's kind of my version of it. So root cause analysis is something where you look at the cause of it. If it was a people cause, then it's not the person's fault. You revise your processes or do better training or something like that. That's a much more positive impact than firing everybody because something went wrong. Which maybe you need to do that if they, you know, do bad, you know, if they mess up more than once, then yeah, maybe they need to go somewhere else. You know, find another bus to get on. Yeah, we've done vulnerability scans. Digital forensics. You can actually lock down and copy what's in memory on a computer at that time. That's beyond my scope, but you can actually take a snapshot of the whole computer, hard drive and memory. I don't know how you do that. Oh yeah, if you do the Network Plus or Security Plus test, you have to know secure the scene, preserve the evidence, all this police stuff, have security, tamper-proof tape, chain of custody. Yeah, I had to memorize all this stuff for my Security Plus check thing. This is getting very specific. Notice there what I can do. You can like store all that stuff. It's interesting. Anyway, that's the gist of this chapter. The Cliff Notes version.